Hello everyone, welcome back to my Chem Corner. So in today's video, we're going to do another topic from solid state. Before we move into the video, if you're new to the channel, please do subscribe to the channel and hit the bell icon so you receive notification of a new video that I upload. So in this video, we're going to talk about electrical properties in solid state. So let's see what the topics are. So in this video, we're going to talk about the electrical properties, which are basically conductor, insulator, and semiconductor. So we all know that conductor is something that conducts electricity and insulator is something which has a low conductivity, which means it doesn't conduct electricity at all. A classic example of a conductor is any metal, right? So if you have any metal, copper or a zinc, any of these would conduct electricity. An insulator like a diamond, which is a classic example that you've learned in first year, that is going to be an insulator. And there's something else called a semiconductor, which has an intermediate conductivity, which means it cannot conduct electricity by itself, but it requires a support of another element in order to show conductivity. So in this chapter, what are we going to focus on? We're going to focus on semiconductor in detail. But before we move into in detail about semiconductor, how the semiconductor is going to conduct electricity and all of that, we will be just brushing through basic things about conductor. So when we talk about conductor conducting electricity, how does it actually happens? Because of what does it actually happens? Or if you're talking about an insulator that doesn't conduct electricity, what is the reason? Why is that so? What are the things that are responsible that insulator do not conduct an electricity? So that's what we're going to just brush up through it. So let's move into that. So here when we're looking at conduction of electricity, we're going to talk about conduction of electricity in a metal, right? So here the conductor conducts electricity through movement of electron or ions. We all know classic characteristic feature of metal is it can give away electrons. Those electrons are the ones that are responsible for conduction of electricity. Now, how much is going to be the conductivity from each metal? It only depends on number of valence electrons that are available. So, if you take each metal, the conductivity value is going to be different for different metals only because it depends on how many electrons are there in the last orbital of every metal. Atomic orbitals of metal atoms form molecular orbitals which are so close in energy so as to form a band. So here, when you're talking about a band, this is what a diagram of a band looks like. So when you're talking about conductors over here, the valence band is nothing but the outer shell electrons that are arranged in the metal. That is basically what the valence band is. Now what happens here is when the electrons are excited, say for example you're trying to heat that particular metal, what is happening? The metal is going to absorb the entire heat, and who's going to be affected with this? The electrons that are present in the valence orbital. So the electrons that are there in the valence band is going to jump to the conduction band, which is the higher excited state. Now, when this electron jumps from the lower excited state, which is the lower state, which is the valence band, to the higher excited state, which is the conduction band, there is a conduction of electricity. So here, the energies are so close that electrons can easily jump to the conduction band. Now, if this band is partially filled or it overlaps with the higher energy unoccupied conduction band, then electrons can flow easily. So here, if the conduction band is very close to the valence band, which means you don't have to apply much energy for the electrons to jump, in that case, you will have conduction easily. Or if you have a partially filled orbital also, these electrons can jump easily. And it can show conductivity also. But if the gap is too large, just like how you see for insulators, the gap between the conduction and the valence band is more. In this case, there is no way the electrons can jump. So here you will see behavior of an insulator, which means they will not conduct electricity. Alright, so that was all about conduction of electricity, just brushing through the basic concepts that you know about conductors and insulators. Now moving on to the main part under electrical properties that we're going to focus on this year is conduction of electricity in a semiconductor. So here we all know, we've just seen the diagram also, that the valence band and the conduction band in a semiconductor is quite small. It's not as small as a conductor. It's not as large as an insulator, right? It's intermediate between both. They're smaller, which means they may jump to the conduction band. How? With increase in temperature. So the gap between the valence band and the conduction band is small in semiconductors, but electrons can jump only when you try to increase the temperature. So that is what we're going to learn under this semiconductor. So when you compare the band gap between each of this, if you see the gap in semiconductor is intermediate between both insulator and conductor. Now, what kind of elements in your periodic table do show these semiconductor character? These are substances like silicon or germanium, basically your group 14 elements. They show properties like a semiconductor. The conductivity of the intrinsic semiconductor is too low for a practical use. So say you want to do some experiment related in the lab, all of those. We don't generally prefer a semiconductor because the conductivity is much lower. So instead they prefer a conductor. Now, how are you going to increase the conductivity? We always say probably by increasing a temperature, you can increase the conductivity of a semiconductor. But there is also a method where when you add small amount of an impurity, you can still increase conductivity, right? By heating, yes, we can increase conductivity. But by adding a small amount of impurity, you can increase conductivity even more. So the process by which you're adding an impurity to a semiconductor so that conductivity increases is called as doping. Alright, so the process here is called as doping. Now, doping, how is it going to be done? You're going to use two types of impurity. One is an electron-rich impurity and the other one is electron-deficient impurity. So, for example, I am having group 14 elements, which is a semiconductor. My electron-rich impurity is going to be group 15 because it has one electron extra. Whereas if I'm talking about electron deficient, then I'm talking about group 13 element because it has one electron lesser. So this way, I'm going to use both group 15 and group 13 to do doping process so that group 14, which acts as a semiconductor, can conduct electricity. Alright, so this was just the introduction to a semiconductor. Now what we are going to do is we are going to learn how a group 13 element is going to help in doping or how a group 15 element is going to help in doping and what are they called as. Alright, so here we are going to use electron-rich impurity, which means I am going to use carbon family, which is the group 14 acting as a semiconductor. My impurity that I'm going to add is from nitrogen family, which is group 15. So in this case, when you're talking about group 14, which is a semiconductor, how many valence electrons do they have? They are going to have 4 valence electron, right? So when we are going to dope it with an electron-rich impurity, we are going to dope it with a group 15 element, basically nitrogen family, which is going to use phosphorus or arsenic. Now, if you say they are pentavalent impurity, what do you call by pentavalent impurity? Which means they contain 5 electrons in the valence orbital. So here, when you see these two, the group 14 is having 4 valence electron, whereas group 15 is having 5 valence electron. So in this case, 4 out of 5 electrons in the group 15 is going to be involved in bonding with group 14 elements. So out of 5 electrons that are there in group 15, only 4 are getting bonded to group 14. Now, what happens to the 5th electron that is there in group 15? The 5th electron is going to become delocalized because it is a free electron now. It is going to move around. Now, when it moves around, it is going to conduct electricity in the electron-rich impurity type of a semiconductor. So here, therefore, you're going to increase conductivity, and this increase in conductivity is only due to that negatively charged electron or that 5th electron that is present in this. So here, because you have that extra electron, this type of an semiconductor where silicon or germanium is doped with group 15 element is called as N-type semiconductor. Why is it called an N-type semiconductor? Because the one that is responsible for delocalization or for conductivity in this case is an electron. Electrons are negatively charged. So here N-type meaning negative type semiconductor, because it's an electron that's responsible for conduction of electricity, which we call this as a negative type of a semiconductor. So this is with respect to an electron rich impurity. But what happens when you have an electron deficit impurity or electron poor impurity? So here, when you're talking about an electron deficit impurity, I'm going to compare group 14, which is a carbon family, with group 13, which is a boron family. So here again, group 14 will have 4 electrons in the valence orbital, whereas group 13, which is added as a dopant, is going to be containing only 3 electrons. So in this case, out of the 4 electrons, only 3 electrons will be involved in bonding. What will happen to the 4th one? The place where the 4th electron is supposed to be present in the dopant is vacant because it has only 3 electrons. So here it is going to create an electron hole or an electron vacancy. Now the neighboring electron can try to fill that particular hole, and that positive charge is the one that is going to be responsible for conduction of electricity in the electron deficit semiconductor. So here what is happening, because you have a vacant orbital in the group 13 element, the neighboring electron can keep shifting in that particular hole. So what is the reason why there is conduction of electricity? It is because of an electron hole. It is because of an electron vacancy. What is the charge of the vacancy? Vacancy meaning it is always lesser, which means positively charged. Therefore, when you have silicon doped with an electron deficit impurity, we call it as a p-type semiconductor or a positive type semiconductor. So there in electron rich, you're going to add group 14 with group 15. In electron deficit, it's going to be group 14 with group 13. So that's the 2 types of semiconductor that are responsible for conduction of electricity only in the presence of a doping. So now that we know what happens in a semiconductor, let's see what the possible applications are. So here it is diode, which is a combination of both N and P-type semiconductor, is used as a rectifier. Transistors are sandwich semiconductors where one layer of one type of semiconductor is sandwiched between 2 other types of semiconductor. This you would have probably learned in physics. How is it going to detect radio signals and all of that? You use this type of a transistor. And last one, which is solar cells, is an efficient photodiode which is used to convert light energy into electrical energy. So these are some of the simple applications that you can have under N and P-type semiconductors. So in case this video is clear to you all, kindly hit a thumbs up and put down your suggestions in the comment box. In case you have any other queries, please don't hesitate to write me an email that's mentioned in the description box. I'll see you in the next video. Stay tuned.